Good afternoon. In today's lecture, we will discuss in details the Enterprise Systems Architecture, which is a definition and representation of a high-level view of an enterprise business process and IT systems, the interrelationship between them, and the extent to which these systems are shared by different parts of enterprise. So after attending this lecture, you will be able to know why you study Enterprise System Architecture, understand different components and architecture of the ERP systems, discover how a well-designed architecture affects the ERP implementation, classify different types of architectures through identifying their benefits and limitations, understand the service-oriented architecture and its impact on ERP systems, and finally, identify the impact of cloud architecture on ERP systems. When ERP systems are successfully integrated and implemented in a company, they become the keystone of the organization, as every single transaction will now be processed through this system. So in order to successfully implement ERP systems, the management and implementation team should have a clear understanding of the ERP system architecture and the specific components which might be required for any business need. If the ERP software is installed with a focus only on the system architecture, the company may have a successful installation of software but unsuccessful implementation. As the ERP implementation is not just about installing a new software or system, in fact, the hardest part is changing the business process of the people who will use the system, because nobody likes process change, especially when the future is vague. So as we discussed in the past lecture of systems integration, it's very important to include the people whose processes are changing within the project planning to measure the level of acceptance before, during, and after the implementation process. That's why it's important to concentrate on systems integration besides focusing on business process architecture, business requirements, budget, project management, commitment from top management, and finally, continuous communication with employees about future changes. Now, let's discuss why should we study enterprise system architecture. Since every type of enterprise systems need an architecture to reflect the blueprint of its software and hardware design, during the design and implementation of an ERP system, we need a blueprint of the actual implemented system that defines the high-level ERP implementation strategy and shows the information flow within the organization subsystems and their interrelationships. The ERP implementation team can develop a successful ERP system when a flexible and well-designed architecture is defined for the system, where such architecture shows how different components of the system are combined and interact with each other in order to provide the most efficient information flow in the organization. Understanding the enterprise system architecture is important for several reasons. First, it helps management and the implementation team to understand the features and components of the enterprise system. Second, it provides a virtual representation of the complex system interfaces among the ERP applications and databases, operating systems, legacy applications, and networks. Finally, understanding the enterprise systems provide a well-defined vision for the management about the system infrastructure requirements, training requirements, changing management requirements, and business process re-engineering requirements to develop an enhanced IT plan. Later in this lecture, we will learn about system architecture components, the Erp modules, types of Erp architecture, and finally, the role of architecture and its impact on the implementation stages of the project. The ERP system architecture provides a base for both the functional and the technical needs of the organization and adapts to future business challenges. ERP architecture defines the relationship between the complex information technology components, including hardware, software, and data, with complicated organization components such as company structure, business rules, and people. As we see in this figure, the components of enterprise system architecture can be viewed from two different angles. First, the functional angle that defines the Erp modules that support different business functions such as accounting, HR, and procurement, while the second one is a system that defines the ERP architecture through the physical components of hardware, software, and network. After discussing the importance of having an efficient ERP system architecture and the architecture model, now let's discuss the advantages of adapting ERP architecture in the organization. The primary objective of ERP architecture is to make the organization as efficient and effective as possible. This could be achieved by aligning business and IT strategies through creating a map of IT assets and business processes to identify the set of governance principles that drive an ongoing discussion and directions about the business refining and future vision of the organization, to increase the business and IT agility and how they can be expressed. The advantage of adapting efficient enterprise system architecture include architecture analysis, which assists in performing system analysis at the architecture level. This helps to support the system design process. The business and system understanding offers a concrete base for effectively understanding the business operations of an enterprise, which results in improved business management. Business and system planning offers a useful tool to plan numerous business activities from strategic directions to local enhancement. Restructuring and system integration helps to make restructuring and system integration possible whenever a change in business operations happens in the organization. Finally, system evolution offers required grounds for evaluating the outcome of major transformation in an organization, such as by replacing old systems with new ones or decommissioning of outdated systems. The architecture domain in enterprise system architecture is a general view of an enterprise or system and a partial representation of the whole system that addresses several concerns of several stakeholders. There are 4 interconnected architecture domains as shown in this figure. The business architecture includes the structure and behavior of a business system and covers business goals, business functions, and business processes. Business functions and business processes are often mapped to the application and data they need. Business architecture addresses the questions of what and who. What is the organization's business visions, strategy, and objectives that guide the creation of system services and capabilities? And who is executing defined business services or capabilities? The data architecture includes the data structures used by a business application and the description of data in storage and data in motion, including data stores, data groups, and data items. Mapping of those data artifacts of data qualities, applications, and locations. Applications architecture addresses the question how. How are previously defined as business services or capabilities implemented? Applications architecture defines architecture and behavior of applications used in a business, how they interact with each other and with users. This architecture focuses also on the data consumed and produced by applications. Applications are mapped to business functions and to applications platform technologies. Technology or technical architecture identifies the behavior and structure of the IT infrastructure, covers the client and server nodes of the hardware configurations, the infrastructure applications that run on them, the infrastructure services they offer to applications, the protocols and networks that connected applications and nodes. In an organization, ERP helps to manage business processes of different departments and functions through the centralized application. We can make all the major decisions by screening the information provided by ERP. Organizations often implement the ERP modules that are both economically and technically feasible. So now let's discuss what are the different ERP modules. ERP systems provide the same functionality to all the users as the past silo systems, but the data are now integrated or shared across the ERP modules. This means that data need to be entered into the system once, and depending on the organization's business rules, they are made available to users either inside or outside the organization. Also, in today's organization, teams are not limited to employees of the company. Teams can include employees from several functional areas or from business partners and customers. ERP systems, therefore, provide access to data as defined by the organization's business rules. There are many vendors in the market who are providing traditional ERP solutions or cloud-based ERP solutions. Some of these vendors will be mentioned next. ERP vendors including SAP, Oracle, and Microsoft provide modules that support the major functions area of the business, such as accounting, production, financial management, human resources, and sales. These modules provide the functionality to implement business policy and processes in accounting, production, finance, HR, and so on. The ERP software embeds the best business practice into the software to allow organizations to implement their policies and procedures. ERP vendors often claim that these business practices will help to improve the organization productivity and performance. For example, a procurement module includes the best practice of purchasing, such as forms, routing, and methods of integrating with e-commerce application. However, some business rules may conflict with the organization policy. Then customization or changes are necessary when implementing the ERP modules, where the ERP software provides different levels of flexibility in modifying the system during implementation. In general, ERP vendors provide a comprehensive range of enterprise software applications and business solutions to empower every aspect of business operations, identify new business opportunities, and enable the organization to respond to changing business environment. They also include functionality to optimize business operations and resources to extend best practices to the entire value chain. In this table, a high-level overview of the usual modules are provided by major ERP vendors. Next, we will explain a brief overview of some of these ERP modules. The key role of an ERP system is to provide support for such business functions as accounting, sales, inventory control, and production for the different stakeholders of the organization. All the ERP modules that we will mention now could be found easily in any ERP system, such as HR, inventory, sales and marketing, purchase, finance and accounting, customer relationship management, engineering and production, and supply chain management. The production module helps in planning and optimizing the manufacturing capacity, parts, components, and materials using historical production data and sales forecasting. Production modules have evolved from manufacturing requirements planning, MRP, into ERP systems with the help of consulting firms who have accumulated massive knowledge of implementing a production planning module. The purchasing module streamlines the procurement process of required raw materials and raw supplies. It automates the process of identifying potential suppliers, negotiating prices, awarding purchase orders to the suppliers, and billing process. The purchase module is tightly integrated with the inventory control and production planning modules. The purchasing module is often integrated with supply chain management software and business-to-business web software. Inventory management facilitates the process of maintaining the appropriate level of stock in warehouse. Inventory control identifies inventory requirements, sets targets, provides replenishment techniques and options, monitors items usage, reconciles the inventory balance, and reports inventory position. Integration of the inventory control with sales, purchase, and finance modules allows ERP systems to generate executive-level reports. As revenues from sales are essential for commercial organizations, the sales modules implements functions of order placement, order scheduling, shipping, and invoicing. The sales module is closely integrated with an organization's e-commerce website, and many ERP vendors offer an online storefront as part of the sales module. On the other hand, the marketing module supports lead generation, direct mailing, campaigns, and more. Within the finance module, benefits both for-profit organizations and non-profit organizations. The financial module is the core of many ERP software systems. It can collect financial data from different functional departments and generates valuable financial reports such as budgets, balance sheets, general ledger, trails balance, and quarterly financial statements. The human resource module is usually the first module implemented by many companies. The HR streamlines the management of human resources and human capital, where the HR modules maintain a complete employee database including contact information, salary, details, attendance, performance, evaluation, and promotions. An advanced HR module is integrated with knowledge management system to optimally utilize the expertise of all employees. The CRM department is helping to increase the sales performance through better customer service and establishing a healthy relationship with customers. CRM module stores details of the customer and helps to manage track detailed information of him like communication history, calls, meetings, details of purchases made by the customer, and contract durations. CRM module can be integrated with the sales module to enhance sales opportunities. Supply chain management manages the flow of product items from manufacturer to consumer and consumer to manufacturer. Common roles involved are manufacturer, super stockist, distributors, retailers, etc. Supply chain management involves demand and supply management, sales returns and replacing process, shipping and transportation tracking, etc. The miscellaneous modules include non-traditional modules such as business intelligence, self-service project management, and e-commerce. The following details some of the key benefits provided by ERP vendors such as SAP, Oracle, and Microsoft for different application modules. In self-services, this module enables flexible support for employees, business functions with views of information to their needs, empower employees and managers through simplified access to relevant information for HR, management, financial operation analysis, while motivating productivity and efficiency. The performance management improves business insight and productivity by delivering real-time, personalized measurements and matrices. Provide executive managers and business workers with access to such information, including business statistics and key performance measurements represented in the context of business tasks. Within the financials, it ensures compliance and predictability of business performance, gain deeper financial insights across the enterprise, and control of finance. Automate financial and managerial accounting and financial supply chain management, and finally provide support for financial reporting, corporate governance. The HR module attracts the right people, develop and leverage their talents, align their efforts with corporate objectives, and retain top performers. It also increases efficiency and help ensure compliance with changing global and local regulations by using standardized and automated workforce processes. Enable creation of project teams based on skills and availability, monitor progress on projects and track time and analyze results. Manage human capital by analyzing business outcomes, workforce trends, and demographic and workforce planning. The procurement and logistics execution sustain cost saving for all spending categories by automating such routine tasks as determining sources and converting them into purchase orders, and by allowing employees to use electronic catalogs to order products and services. Reduce costs through process automation, integration of suppliers, and better collaboration. Enhance productivity of all activities related to incoming and outgoing physical goods. And finally, reduce transportation costs through better consolidation and collaboration. The product development and manufacturing shorten time to market through streamlined new product development and introduction processes. Deliver highly quality products and ensure delivery of promoted orders, and improve the visibility and transparency in real time across all shop floors processes, including availability, checking, and costing. The sales and service modules increase the number of sales orders, deliver greater customer satisfaction, improve the management incentives, reduce travel costs, and realize more effective real estate management. Now we will talk about the ERP architecture. The architecture of ERP system plays a major role to determine its success and durability for the institute. Today, there are four major known architectures for the ERP systems. The first is the three-tier architecture. Another architecture is called the web-based architecture, and the service-oriented architecture, and finally the cloud computing architecture. In today's business environment, ERP applications are most deployed in a distributed and often scattered way. While the servers may be centralized, the clients are usually spread across several locations. Erp Systems Architecture is organized in layers or tiers to manage system complexity in order to provide scalability and flexibility through a plug-and-play systems, which is very important in enterprise-level systems. The three layers architecture is the most common architecture now and includes web, application, and database servers. It is the most reliable, flexible, and scalable architecture. You can scale the number of users from 1 to 10 by adding servers. This is one example of simple hardware layering that has an important impact on scalability. What if the layering is done at both the hardware and software environment? The answer for these questions is that the scalability would be 20-fold instead of just 10-fold. Therefore, it's important to understand that layering is a model of dividing the hardware and software in an information system, and it's not limited to 3 tiers, but often supports many other tiers. This is why the term N-tier client-server architecture is often used to describe enterprise system architectures. In the term N-tier, N indicates a number, such as 3, 4, or any number of tiers used in your architecture. An example of layered ERP architecture is the Infonet Architectures. This type of architectures generalize the functional layers to allow it to change with newer technologies and provides a web-based user interface in which user can access the application through the internet and using a PC. The PC needs to be capable of running a Java-enabled web browser such as Internet Explorer or Firefox. The PC is connected to both Internet and Internet to be able to use one of the Infonet servers. The user interacts with the Java Virtual Machine Interface layer to establish a secure connection via the Secure Socket layer connection, where the user is then communicating with the server through the application software layer. In this figure, we see an example of a layered ERP architecture, which is Infonet Architecture. The SQL layer is available to users who have security clearance. SQL Peek gives the users point and check access to filter and sort the data in any table. It also allows the user to create and run complex exception reports. The SQL system also can be used to define custom reports that can be used by users' menu. Application software layer is where all the business functions and workflows are defined. The ASL is the host of all business rules, logic, and functions that are required to operate in manufacturing, distribution, or service business. The ASL contains all the business logics that defines how the application programs do their jobs. Through an application programming interface API, ERP systems allow legacy and third-party applications to integrate and share information. There are 2 basic architectures of integration. One is where the application will make a direct Java database connection, JDBC, and call another application's data tables directly. The second is the middleware-based integration that provides generic interface where integrated applications can pass messages to each other's. Database Access Layer, DAL, is designed to abstract the application from the database. This layer contains the definitions of the different database functions that the application uses. By defining the functions in this layer, we gain the ability to switch to any relational database. The layer of the relational database, RDB, is where the business data is actually stored. The RDB also contains the data definition that defines and links a sales order items, delivery, and remarks. It supports the MySQL and C-Script relational databases. Hardware operating system layer is the hardware operating system combination that server-based applications run on. Traditional network requires upgrading prior to the deployment of ERP system and must be a component of the overall budget. A high availability network is a requirement for a fully functional ERP systems, one that grows with the user population and supports continued expansion and integration of the supply chain. Integration with partners and customer systems allow the company to manage important parts of the business such as order tracking, inventory management, etc. Online analytical processing, OLAP services, provide the availability to access, present, and analyze data across dimensions. The three-tiered architecture is composed of 3 layers: presentation, application, and database, as shown in the figure. Most of current ERP implementations follow the three-tiered architecture. Segmentation of these tiers allow for the system to be more scalable and reduces resource utilization. It also provides higher security due to the separation of resources. The three-tier architecture is a scale-up of the client-server two-tier architecture. As shown in the figure, there is a comparison between the 1, 2, and 3 tiers architecture. In the 3-tier, the client is no longer directly communicating with the database, as a layer responsible for carrying out the business logic is introduced. In this architecture, the presentation layer is only responsible for browsing the data and providing user-friendly interface, which allow the user to have less powerful machines. However, the application layer in this architecture is where the data gets retrieved and transferred to the database server in the database layer. The application layer is also where the logic and the business rules are implemented. There are 3 different types of tiers: the web, the application, and the data. In the web tier, portals allow users the ability to access and analyze information through their web browsers. Network security within the web tier is extremely important, as this is the front door to an organization ERP system. Whether the system lives internally or externally, there is a risk of someone breaking the system. The first line of defense should be a firewall that is located between the web tier and the connection to the rest of the network. The application tier provides components to apply the business logic of the functional modules. It acts as the intermediate between the client application and the database. The application tier consists of a web browser and reporting tools where business process and end users interact with the system. It shields the business users from the inner working of an ERP system, but still provides the information relevant to their jobs and business processes. Data tier is responsible for data management. This layer allows sharing of all data between the functional modules and maintains the integrity of data transferred to and from clients and servers, and focus on the structure of all organizational data and its relationship with both internal and external systems. The 3-tier architecture provides several benefits over traditional client-server application, including scalability, where the 3-tier architecture allows easier architecture to add, change, and remove applications because the user interface and database are not affected by upgrades to the applications. 3-tier architecture makes it easier to increase reliability of the system by implementing multiple levels of redundancy. Besides, the scheduling and giving priority to jobs can be managed better from a central location. flexibility by separating the business logic of an application from its presentation logic. Three-tier architecture makes the application much more flexible to change. Flexibility in partitioning can be simple as dragging and dropping applications code into different computers. Support and maintenance costs are less on a single server than it would be to maintain each installation or upgrade on a desktop client, because the middle layer adds scheduling and priorities for work in progress. Reusability includes separating the application into multiple layers, makes it easier to implement reusable components. And finally, the security. Three-layer architecture provides higher security because there is less software on the client machines, which means the IT staff has more control over the ERP systems. Three-tier applications also have some limitations, including economics, where the three-tier applications require additional hardware and software infrastructure to support the middle layer, which can increase the overall platform cost. A key limitation with three-tier architecture is that the development environment is more difficult to use than the visually oriented development of two-tier applications, which increase the complexity of using the three-tier architecture. Now we will start talking about the web service architecture, which makes use of the web technologies and concepts to deliver simple and real-time assets to Erp modules for the end users and streamline the flow of information between systems. Web service technologies can offer many capabilities to enterprise software systems and inspiring more Erp vendors to adapt and transfer their architecture in order to use the advantages of these technologies and provide powerful functionalities. Web-based architectures use object-oriented technology to apply a mixture of data and functions available in web service methods in order to provide services to different applications. Web-based architecture, often described as the fourth tier, where the web tier is split into web service tier and web browser tier. As shown in this figure, the Erp system focuses on the internet to provide a powerful new functionality for internet-based access and integration. This functionality is primarily supported through the following internet access technologies, such as the web server, the Erp portal, back-end server integration, and browse plugins or applets. The key benefit of using the internet platform at the foundation is that organizations can provide a wide range of end users with access to Erp applications over the web, as well as more easily integrate their Erp applications with existing internal systems and external trading partner systems. The internet architecture can be either server-centric or client-centric. The server-centric architecture enables secure end-user access to Erp applications modules from any internet-enabled device that uses such standard internet technology such as HTML or XML, which can access and execute Erp applications. The benefit of server-centric architecture is that there is no complex, expensive client software installation, while the internet client device accessing the internet architecture already has all the softwares and configurations it needs. No additional softwares need to be installed on the client for interaction with Erp applications. Simple open architecture creates easy and inexpensive access, which justifies why the web has been such a fast-growing success. On the other hand, the client-centric architecture requires application and data to be installed or downloaded from a server and executed from a client workstation. Each architecture has its benefits and drawbacks, although the server-centric architecture has better security and controls because all applications and data are not on the clients but are stored on the server, do not need any specific configurations, it does tend to have slower response time because all users' requests are processed to the server. The client-centric architecture has better response time because users' requests are mostly processed on the client's computer. However, they can lack security and require all client workstations to be set up according to the standards specifications. In addition to improving end users' access, Internet-based architecture also allows better system-to-system integration, which is more complicated and costly. The web system platform fundamentally supports a better and more open flow of information between systems, where the ERP system supports better system integration using integration technologies, which streamline integration of ERP modules with other organizational applications, custom internal systems, e-merchants, and customer trading partner systems. This functionality is supported through the following web technologies, including application messages, component interfaces, business interlinks, and application engines. Service-oriented architecture represents object-oriented architecture for web platform. Service-oriented architecture is a style of software design where different functions are provided to the other components in the form of service through a communication protocol over a network. A service is well-defined, self-contained, and discrete unit of functionality that can be accessed remotely and independently updated. For example, retrieving a credit card statement online can be implemented as a service. ERP systems can implement service-oriented architecture by decomposing the business logic layer into smaller, distinct units of functionalities as services, where these services can provide the modular function of ERP system. A service can then be used anywhere in the modules of the ERP systems, where the services in the service-oriented architecture must comply with certain design principles and standards. For each service, there is one provider and one or more consumers. Two or more services can coordinate some activities for a business function. Since services are independent of the operating system platform, a consumer from a device with any operating system written in any language can use any service provided that is use the service-oriented architecture, standard protocols, and specifications. In service-oriented architecture software development model, a contract is implemented between a consumer or client and a provider that identifies the following: a description of the service function, a specification of service input and output, the state of environment before service can be called, the state of the environment after service has been provided, and finally, error handling when there is an exception. Unlike the three-tier and web-based architecture, the service-oriented architecture is not based on a certain technology or networking techniques. Service-oriented architecture is an approach used to create an architecture based on the use of service, regardless of the networking methodologies used. With the institution growth, the number of services it required to deliver increases. With that, single system would not be able to keep up with the number of transactions. Therefore, a system for each service is launched, where service-oriented architecture allows organizations to customize and modify their ERP systems easily. In addition to that, service-oriented architecture encourages reusing existing services. It's worth mentioning that the communication across the different systems would be hard if regular interfaces are used, as they would be very expensive and intensive to develop. Service-oriented architecture offers the following benefits over traditional approaches, including business-level software service across heterogeneous platforms, complete location independence, service can exist anywhere, loose coupling across application services, authentication and authorization support of service unit level, dynamic search and connectivity to each services. There are also short-term benefits of service-oriented architecture, such as enhancing reliability of the architecture, reducing hardware acquisition costs, accelerates movement to standards-based servers and applications, providing a data bridge between incompatible technologies, while the long-term benefits include the ability to build composite application, creating a self-healing infrastructure, providing truly real-time decision-making applications, and enabling the compilation of a unified taxonomy of information across an enterprise and its customers and partners. The business value benefits of service-oriented architecture include increasing the ability to meet customers' demands, lower costs associated with the acquisition and maintenance of technology, empowering the management of business functionality, leverages existing investments in technology, and finally reduces reliance on expensive custom development. Service-oriented architecture implementations are costly and time-consuming. It requires complex security firewalls in place to support communications between services, while performance can be inconsistent. Service-oriented architecture requires enterprise-level focus for implementation to be successful. Security system needs to be very complex, and cost can be high because service needs to be joined very often. The final architecture we are going to discuss is the cloud computing architecture. Cloud computing has recently emerged as a powerful platform to support the growing needs of many organizations that do not want to own and maintain complex software systems for the enterprise. There are high costs of software purchasing and maintenance. IT staff have to be contented with networking, technical support, and security, in addition to managing privacy, compliance, and other issues, which makes it very expensive to own software. The cloud computing platform provides a great alternative for these organizations as they do not have to purchase, install, or maintain the software applications or manage security of the installed systems. The cloud computing platform is risky for organizations as it forces them to rely on cloud computing vendors for security and continuity of enterprise applications. However, as the cloud computing platform settles down in near future, and with large vendors like Microsoft, Oracle, and SAP starting to integrate their applications and services on these platforms, more organizations will adopt these platforms. The cloud computing platform provides a great alternative for organizations that do not want to purchase, install, or maintain software applications, or worry about security, privacy, and legal issues associated with data storage. The cloud computing platform is risky for organizations as it forces them to rely on external vendors for security and continuity of enterprise application usage. Enterprise content management deals with enterprise software products that usually store, preserve, and manage the delivery of content connected to business processes. Enterprise content management also about supporting business goals, not just managing content. Vendors have come to an understanding that content management takes advantage of technology and information assets across the business and is no longer application specific. There are several benefits of cloud computing, including the real-time analysis, where one of the greatest benefits of using cloud service is accessing a real-time analytics. This allows companies to see important information when it comes to availability, which can help to make important decisions and ensures process optimization. Accessibility is one of the great features of the cloud. So, if you have an internet access, all the information you need is available from any location at any time. As mentioned previously, on-premises ERP systems need manual and continuous maintenance to keep up with hardware-software updates, which can negatively impact your company's budget. Using cloud service lowers the cost of operation. Cloud ERP software also scales easily as it adjusts the entire infrastructure to the necessary size for each stage in your development as a company. With on-site infrastructure, scaling can be costly and complicated, so the cloud just simplifies this entire process for you. Since the cloud is a subscription-based model, service support is available 24/7 for any issues that might happen. Cloud computing has several drawbacks, including data security, possible conflict of interest if the company who stores your application decides to create a similar application, not suited for all highly competitive industries like biotech, where intellectual property cannot be protected easily. This table shows different architecture styles of ERP systems which are applied in ERP design for the modern age. For each architecture style, important characteristics, the benefits and drawbacks are presented. In the next section, we explore the most important technologies applied in ERP solutions, which are provided by some of the most popular vendors in ERP market, with all the benefits that the three-tier architecture brings to ERP software. Most ERP vendors have moved to build their solutions based upon the beneficial architecture and try to enrich if using modern technologies in the IT world. On the other hand, the rapid growth of cloud computing technology has made it possible to host any type of software systems, including ERP systems, in the cloud using the benefits of transparency and scalability of the cloud environment. You could revise this table. It's a summary of the information related to the architecture of some well-known ERP systems in the market. As mentioned previously, the world market has commenced and will continue a fast movement to make the best use of cloud service and infrastructure for providing ERP products and services. This figure shows SAP System Architecture with its three layers. The database layer, which stores all the data needed for the ERP system, can include a relational database such as Microsoft SQL Server or Oracle. The application layer includes a set of servers which are responsible for background processing and request management. The presentation tier provides graphical user interface for end users access to the system using front-end clients which serve as interface. The front-end client presents SAP screen and provide tools for them to enter inputs to the system and receive appropriate output. The application layer provides a range of services for the operation of the SAP system. The application server's processes are carried out through work processors, which are components that can execute a desired request. Each worker processor is registered as a user in the database system for the entire runtime of the SAP system. A dispatcher collects the requests and distributes the workload to the different work processes. SAP has developed a modern web-based open integration application called Netweaver, which serves as a technical base for many SAP applications. The Sap Netweaver is a comprehensive platform for development, composition, and maintenance of the enterprise system, as shown in the figure. SAP Netweaver application server hosts all applications such as business process management, data warehouse, online analytical processing, and extending applications to mobile devices. The architecture of SAP Netweaver is composed of 4 layers: application platform layer, process integration layer, information integration layer, and people integration layer. Therefore, SAP Netweaver can provide a framework for integrating people, process, and information, where VMware, a giant vendor for cloud computing services, has cooperated with SAP company to provide a virtualized version of entire SAP landscape, which can be used for testing, development, training, and production environment. The SAP virtualized solution can provide many benefits for the client's organization: high availability with automated fault tolerance and zero downtime or data loss, faster time to value with rapid and automated provisioning, lower total cost of ownership through automated data center operations, applications, provisioning, and infrastructure delivery, and the better data protection, security, and compliance. Oracle NetSuite is one of the most popular ERP vendors and the world's largest cloud ERP provider, which has consolidated its position as the market leader for ERP products. It provides a complete package of cloud-based applications in the form of software as a service, including financial management, enterprise resource planning, human capital management, customer relationship management, and the professional service automation. The Oracle Developer Tool include workflow management, scripting, analysis, web service, and more. It provides a graphical customization tool for powerful records and field management for building business forms. The final section of our lecture today is implications for management when implementing ERP systems. Managers implementing ERP systems should remember that enterprise architecture is an important technology for the long-term functioning of the organization, as it provides the information system based on which all the employees and other stakeholders of the company will depend for important information and for the decision-making process. ERP architecture decisions are complex because their impact goes beyond systems and technology to people, organizational policy, and business processes. Management, therefore, must not leave these decisions for the IT department alone and work together in selecting the architecture. The management involvement must also be at both the functional and physical levels of the architecture to look at the different types of ERP systems architecture and select the most appropriate for their organization. ERP architecture must be flexible to support a diverse set of hardware and software platforms. From the system's perspective, management needs to be aware that for diverse technologies to operate smoothly, the IT group must have a standard and policy for technology decisions. From CEOs to customer support perspective, people in the organization need live access to data anywhere and anytime. Also, customers, suppliers, and other external entities may require accessing information from the ERP system. Do not get carried away with ERP technology hype. As discussed earlier, when the people and organizations processes are not in tune with the architecture, then even a good system will not be able to achieve success in improving the bottom line. Management must learn how to filter out the hype technologies that do not provide values to their organizations. For example, service-oriented architecture may not be appropriate for a company that has a small-scale ERP for internal operations. On the other hand, it may be appropriate for a company with e-commerce applications that has B2B relationships with several of its partners and vendors. System architecture provides answers to several questions such as: how will the system look like? How will the system work? How will it be developed? Do we have the required infrastructure to support the system? Can the system be used for any business functions? This lecture have provided answers to all these questions and other questions related to enterprise system architecture. System architecture includes ERP modules and ERP architecture. Major vendors such as SAP, Oracle, and Microsoft provide modules to support such basic business functions as accounting, finance, marketing, and HR, to such advanced business functions as self-services, compliance management, and business intelligence. This functionality is evolving as needs of organization change. The focus today is on supporting enterprise-wide needs of the company. This means ERP systems are accessible by a wide variety of people and departments, making them complex from management and maintenance perspective. The different types of layered architecture includes the two-tier architecture, which is the simplest form, the three-tier architecture, separate applications from presentation layer, and the web-based architecture that provide a better integration with internet technologies. Another architecture is service-oriented architecture that separates the service provider from the service consumer by making them sign a service level agreement contract that specifies how the consumers requests the service and what information and services will be provided. Finally, management must be involved in the design of the architecture from the very beginning of the ERP implementation project, because the system has a wide and long-lasting implications on the organization. Thank you and see you next week.